poor interface. 2. Frequently potential silent of data management systems have been deterred by an unfriendly interface. The computer interface for accessing a data store is sometimes difficult to remember for the occasional inquiry. People become frustrated and give up because their requests are rejected and error messages are uninitialized. Delays. Globalization and technology have accelerated the pace of business in recent years. Managers must make more decisions more rapidly. They cannot afford to wait for programmers to write special purpose programs to retrieve data and format reports. They expect their questions to be answered repeatedly, often within a day and sometimes more quickly. Managers or trained support personnel need quality languages that provide repeat access to the data type need in a format that they want. Lack of reality. Organizational data stores must reflect the reality and complexity of the real world. Consider a typical bank customers who might have a personal checking account, mortgage account, credit card account, and some certificates of deposit. When a customer requests an overdraft extension, the bank officer needs full details of the customer's relationship with the bank to make an informed decision. If customer data are scattered across unrelated data storage, then those data are not easily found, and in some cases important data might be overlooked. The request for full customer details is relationable and realistic, and the bank officer should expect to be able to enter a single simple query to obtain it. Unfortunately, this is not always the case because data management systems do not always reflect reality. In this example, the reality is that the personal checking mortgage and credit card account and certificates of deposit all belong to one customer. If the bank's data management system does not record this relationship, then it does not mimic reality. These markets is impossible to retrieve a single customer's data with a simple query. A data management system must meet the decision-making needs of management. How must be able to request both rounding and ad hoc reports. In order to do so effectively, a data management system must reflect the complexity of the real world. If it does not store requested organizational data or record a real world relationship between data elements, then many managerial queries cannot be answered quickly and efficiently. Lack of data integration. There is a general lack of data integration in most organizations. Not only are data dispersed in different forms of organizational memory, e.g., files and image stores, but even within one store's format, there is often a lack of integration. For example, many organizations maintain file systems that are not integrated. Appropriate files is in the accounting system may not be linked to the production system. This lack of integration will be a continuous problem for most organizations for two important reasons. First, earlier computer systems might not have been integrated because of the limitation of available technology. Organizations created simple file systems of support a critical function. Many of those systems are still in us. Second, integration is a long-term goal. As new systems are developed and old ones rewritten, organizations can evolve integrated systems. It would be too costly and disruptive to try to solve the data integration problem in one step. Many data management problems can be solved with present technology, data modelation, and relational database technology. Topics covers in section 2 of this book help overcome many of the current problems. A brief history of data management systems. Data management is not a new organizational concern. It is an old problem that has become more significant, important, and critical because of the emergence of data as a critical resource for effective performance in the modern economy. Organizations have always needed to manage their data so that they could remember a wide variety of facts necessary to conduct their affairs. The recent history of computer based data management system is depicted in the following figure. File systems were the earliest form of data management, limited by the sequential nature of magnetic type technology. It was very difficult to integrate data from different files. The advent of magnetic disk technology in the mid 1950s stimulated development of integrated file systems, and the hierarchical database management system (DBMS) emerged in the 1960s, followed some years later by the network DBMS. The spatial database or geographic information system GIS appeared around 1970. Until the mid 1990s, the hierarchical DBMS, mainly in the form of IBM DL by I product, was the predominant technology for managing data. It has now been replaced by the relational DBMS, a concept first discussed by Edgar Frank Court in an academic paper in 1970, but not commercially available until the mid 1970s. In the late 1980s, the notion of an object-oriented DBMS, primed by the ideas of object-oriented programming, emigrate as a solution to situations not handled well by the relational DBMS. More recently, the head of Destination File Systems (HDFS) has emerged as a popular alternative model for data management, and it will be covered in the later part of this book. This book concentrates on the relational model, currently the most widely used data management system. As mentioned, section 2 is developed to the development of the necessary skill for designing and using a relational database, data information and knowledge. Often the terms data and information are used interchangeably, but they are distinctly different. Data are raw, unsummarized, and analyzed facts. Information is data that have been processed into a manageable form. A list of a supermarket's daily receipts is data, but it is not information because it is too detailed to be very useful. A summary of the data that gives daily determined totals is information because the store manager can use the report to monitor store performance. The sum report would be only data for a regular regional manager because it is too detailed for manageful decision making at the regular level. Information for a regional manager might be a weekly report of seller by department for each supermarket. Data are always data, but one person's information can be another person's data. Information that is meaningful to one person can be too detailed for another. A manager's notion of information can change quickly. However, when a problem is identified, a manager might request finer levels of detail to diagnose the problem's causes. Thus, what was previously data suddenly becomes information because it helps solve the problems. When the problem is solved, the information reversed to data. There is a need for information systems that let managers customize the processing of data so that they get information. As their needs change, they need to be able to adjust the detail of the report they receive. Knowledge is the capacity to use information. The education and experience that managers accumulate provide them with the expertise to make sense of the information they receive. Knowledge means that managers can interpret information and use it in decision making. In addition, knowledge is the capacity to recognize what information would be useful for making decisions. For example, a seller manager knows that requesting a report of profitability by product line in useful when she has to decide whether to employ a new product manage those when a new information system is delivered. Messenger need to be taught what information the system can delivers and what that information means. The relationship between data, information, and knowledge is difficult in the following figures. A knowledgeable person requests information to support decision making. To fulfill the request, data are converted into information. Personal knowledge is then applied to interpret the requested information and reach a conclusion. Of course, the cycle can be repeated several times of more information is needed before a decision can be made. Notice how knowledge is essential for grasping what information to request and interpreting that information is terms of the required decision. The relationship between data, information, and knowledge. The challenge. A major challenge facing organizations is to make effective use of data currently stored in their devices data management systems. These challenges exist because their various systems are not integrated and many potential clients not only log the training to access the systems but often are unaware what data exists. Before data managers can begin to address this problem, however, they must understand how organizational memories are used. In particular, they need to understand the relationship between information and manager decision making. Data management is not a new problem. It has existed since the early days of civilization and will be an enduring problem for organization and societies. Alice Landes was enjoying the luxuries of first class travel